Alrighty, it's time. We're gonna peel back the surface and we're going to look into how Python works. This is going to be a pretty intense section of this week's lesson, and I want you to take your time to make sure you understand it because I promise you it's going to be worth it. It's an incredibly satisfying thing to understand, and it's going to answer a lot of questions you may not even know you had before this. Let's start with something that maybe looks a little bit familiar. Here's a program. I'd like you to take a second to think about what might get printed over here. Notice that we're creating a variable called x, setting it equal to 28. We're passing it into this change value function, which turns the parameter into 42. And then once the function returns, we go ahead and try to print it. So take a second. What do you think is going to be printed over here? I'm not going to spoil the answer immediately, but I do want to go through this step by step. So let's start with the very first line of code. X equals 28. What's going to happen is that we're going to make a box in our main function labeled x, and it's going to point at the value 28. Once that happens, we're then going to time to call the change value function. So let's go ahead and call the change value function. Because we're passing x as a parameter into change value, which is calling it n, we're going to have both x and n looking to be the value 28 over here. So that's just generally how parameter passing works. Because 28 was equal to x over here, 28 is equal to n over here. Now on this next line of code, we're going to go ahead and change n to be equal to 42. So what that's going to mean is that under the hood, we're going to take this n, which is currently pointing at 28, we're going to make it point at 42 instead. Now this is a really important step. Notice that we didn't change this 28 to be a 42. We just replaced what n was pointing at in the first place. So now only change values variable is set to 42, meaning that when the function returns and its variables all go away, x is still equal to 28. And so when we print x, we follow the arrow to the 28, and that's what we print. So if you predicted that we'd print 28, awesome, great job. You have a great sense of how variables work when we pass them as parameters. If you predicted 42 or some other number, I'd recommend making sure you understand now why this is going to print 28. You might want to try actually writing this program in the IDE to make sure you understand each of the steps. But now let's twist this a little bit. Let's say that if x wasn't a number and was instead a list, and instead of changing it to be equal to 42, we appended 42 to the list, what would happen? So yet again, take a second to think, what do you think is going to be printed in this particular case? Again, we're creating a variable, we're passing it into this function over here, and we're printing it afterwards, and inside the function, we're just modifying the value. And we already saw that in this program over here, this modification did not hold once we got back up here. So take a second to make a prediction, and then once you're done, join me again to think about how this is going to work. So once again, let's start by starting at the very first line of code. So at the start of the program, the main function's mylist variable points at 42, 28, 7. That's the list that we've just created. And then yet again, we're going to call the change value function. So we call the change value function, and again, change value now has a variable called lst. That's this parameter over here. And lst is pointing at the same list that the mylist variable in main is pointing at. So that's what happens there. And now what's next happening is that we need to append 42 to lst over here. So how does that work? Well, in general, when we call .append, what we're doing is we're following this arrow to the list over here, and we're going to append a number over there. So what that means in this particular case is that we follow this arrow and we change this list to have a 42 inside it. So what does that mean? That means when the change value function finishes and all its variables go away, it's still like we have 42 over here at the end of this list. So the list remains modified, and so when we print the list, we print the list with the appended value over here. So that's a really subtle distinction, because despite having a program that looks exactly the same except for this line over here and this line over here, something is profoundly different. In one case, we did not save the change that was made in this function over here, and in the other case, we did save the change that was made, as we see over here. Okay, so let's dive a little deeper into this. Let's say now, instead of appending a value like we did in the last case, we instead are making a new list over here. So in the last slide, we had lst.append 42, and now we have lst equals blank. Take a second to think, what do you think is going to happen over here? Are we going to clear out this list, or is something else going to happen? So the short answer actually is that something else happens. Rather than resetting what's in this list over here, we instead make a new list, and LST is now pointing at this new list over here. So the key distinction was that rather than appending, we made a new list over here. In fact, this program is a lot more like the first program I showed you with the integers, where we're changing the value of the list rather than modifying the list that already exists. Okay, so what exactly is going on over here? Let's go back to the program I showed you at the very beginning, where we had main and change value each pointing at the 28, but then we got to a point where x and n were both pointing at different values over here. The key distinction over here is that variables like integers, floats, and strings, the variables that you've maybe been using the most in this class so far, are what we describe as immutable. Now, immutable is kind of a scary looking word, but really the root of this word is mutate, which means to change. And the idea over here is that when the Python language was first designed, the people designing the language made the decision that integers, floats, and strings cannot be changed. So when we create this value, 28, we cannot change that 28 to be something else. What we can do is make a new integer, like we did over here, and have our variable point at this new integer. But that 28 is always going to be equal to 28. So more formally, the idea is that you can't modify the value of an immutable variable like x, which is pointing at 28, or n, which is pointing at 28, except by setting it equal to a new value, which is what we did over here, where we set n equal to the new value 42. On the other hand, lists and most other data structures in Python are mutable, meaning that we can make some modifications to the value without creating a new one. For example, when we appended to the list, we didn't have to create a new list to do that. We modified the same list, so that at all points throughout our program, the main function and the change value function were pointing at the same list. So when one made a modification, the other made one as well. Now, this is a really difficult thing to reason about because it's just so confusing and so counter to how we expect it. But I think there's a metaphor that kind of helps us understand this a little better. Now, Mehran has mentioned before that a variable is like a suitcase with a luggage tag. Now, let's revisit this a little bit instead. And let's say that rather than being a luggage tag attached to the suitcase, it's instead like the luggage tag that you carry with you on a plane that tells you what your bag is once you have to pick it up on the travelator. So here's the difference between these two things. What we're doing over here is we're saying that n is a luggage tag equal to 20 that is pointing at 28 sitting in the airport. And what we do when we make this change is we take what's on our luggage tag in our hand, we erase it, and we write down another location instead over here. So what that means is now looking at the piece of paper, I don't know where my old bag was. I only know where my new bag is. So what we're essentially saying is that while both main and change value are holding luggage tags, change value has changed what its luggage tag is saying, so that main and change value's luggage tags are no longer talking about the same suitcase. In this case over here, the situation is slightly different. Main and change value both have a luggage tag that are talking about the same suitcase, But when change value appends to the list, it's not erasing what's on its luggage tag. It's looking at its luggage tag, it's going to the suitcase, and it's putting something inside the suitcase and then going away. What that means is that when main now goes to look at that suitcase, whatever change value put inside there is still there. So that's kind of the key distinction over here, that in one case, we're changing what's on the luggage tag, and in the other case, we're changing what's in the suitcase. Only one of those things is shared between both functions. Now let's talk about that last case over here, when we had LST create the new list instead. The only way to make a new list, in fact, is to explicitly ask for a new one by saying LST is equal to this. And what that does under the hood is it goes ahead and takes this list over here, it makes that list from scratch, and then says, okay, LST is now equal to this. So this, sort of, to use our tenuous airport metaphor, is the same as saying that main and change value both have a luggage tag pointing at the same suitcase, but then change value goes ahead and buys a new suitcase at the airport for some reason and replaces the description of its suitcase with the description of the new suitcase. So now main is still talking about the old suitcase, and change value is talking about the brand spanking new suitcase. So even if change value goes ahead and puts something in the new suitcase, main is still going to be looking at the old one. All right, so now that we understand that, let's talk a little bit about how we can summarize all of this. We've identified two types of variables. We've identified immutable variables and mutable variables. And I think in a lot of the time, it's more helpful to describe these as immutable values and mutable values, because really we're always talking about what's on the right side of the arrow, the value that the variable is currently equal to. Now, immutable values are values like integers, floats, booleans, and strings. These are values that the designers of Python just decided could not be modified. They were fundamentally equal to what they were, and you cannot change them. Now, practically speaking, what this means is that if you pass a immutable value into a function as a parameter, it's not going to be modified. It will remain the same once the function is done. And we get new immutable values anytime we try to change them at all. If we try to set x equal to 7 and then equal to 8, we're getting a new immutable value 8, as opposed to changing that 7 into an 8. Mutable values, on the other hand, are a little more flexible. So we know for now that the lists are mutable, and we'll talk about a few more data structures that are also immutable later on. The high-level idea is that parameter values can be modified. For example, I showed you that change value function, which appended a value to our list, or equivalently could pop a value from our list. Those would be the equivalents of putting something in the suitcase or taking something out of the suitcase, and those sorts of changes persist. The only time we can get a new mutable value is when we explicitly ask for one by using the equal sign to say my list equals a new empty list. Now, I know I'm going pretty far with the whole suitcase metaphor, but I promise even today, after 5 years of studying computer science and 3 years working as a software engineer, I still think it helpful to sometimes think about the suitcases. Now, the working definition I can kind of provide about immutable and mutable variable types is that immutable variable types, kind of the only way to change what's in the suitcase is to buy an entirely new suitcase which has different stuff inside it. A mutable variable is kind of more how you would expect a suitcase to behave. You can take whatever you want out of it and put whatever you want back in it. And so maybe as you're trying to reason about how your parameters behave, it might be helpful to go back to the suitcases and think about whether you need a suitcase that you can change and put stuff back in, or a suitcase that you're comfortable buying a new one of. Now, there's something that I always get this question, and that is, why are some of these variables immutable and some of them mutable? It would be so nice in order to be able to just change any variable in a function and expect it to persist. And I agree, I think there would be benefits over there, but there actually is a really interesting conversation as to why some variables can be immutable. I don't quite want to jump into that in this lecture, but I certainly recommend you follow up with your section leaders or ask in the forum about this. There's a really beautiful sort of design conversation involved in how a lot of these decisions get made, and any of the teaching staff would really love chatting with you about this. That said, I do want to connect this now to something that you may have already seen and not thought that deeply about, and that is that there's actually one other mutable variable that you have seen before, and that is the graphics canvas. So let's take a look at this program, which is a much simpler version of some of the graphics programs you might have written already, where we create a canvas, we pass it into this object, this function over here, and we then draw an oval on it over there. Now, just like in the lists example, you'll notice that the circle does actually show up. It doesn't just go away when the function is done. And the reason for that is because canvases are mutable. So when we have a canvas parameter in main and a canvas parameter in draw, they're both pointing at the same canvas. And just like our suitcases, what we're doing is we're trotting over to our canvas over here, we're drawing a circle on it, and then we're going away, so that when the main function goes to the canvas, the circle is still there. So hopefully this kind of clarifies why the canvas works a little bit differently than some of the other parameters you may have used before. All right, so that is a lot for me to have shared with you in just 15 minutes or so. I strongly recommend writing a couple programs or looking at programs you've already written to understand what kind of suitcases you're passing around. One other thing you could do is try to write a program that takes a list as a parameter and modifies it in some way. We'll do a couple of those a little later on. All right, one other thing I want to talk about before we mercifully call it on the deep dive into Python over here is the for loop. So we talked about these two kinds of for loop before, the for I in range for loop and the for lm in numbers for loop. And I want to talk a little bit about what's happening under the hood over here. So in this particular case, you'll notice that we have this while loop over here, or excuse me, this for loop over here that's looping over the indices. And in this case, we've just got a for loop that's looping over the elements themselves. Now, you'll notice that down here, I've got our variables themselves. I'm skipping the I variable down here because we all know that it's going to be equal to 0, 1, 2, and 3. And I want to talk about how the other variables are going to change. So on the left, we've got my list, which is equal to 1, 2, 3, and 4. And on the right, we've got my list, which is these numbers over here. And then we've got the for loop, which is defined as this new variable lm. The high level idea I want you to get over here is that only one of these loops, the one on the left, is actually successfully going to modify this over here. Let's go ahead and take a look at how this happens. So first of all, we'll notice after the first loop completes, on the left over here, we've actually added 1 to the first element of the loop. We've gone from 1 to 2, and then on this side over here, we've added 2 to lm, but lm is a copy of what's in the list. It's not the same as what's in the list, again, because these elements are immutable. So what that means is that we've added 2 to lm, but not to the list itself. We can keep on going. You'll notice that we successfully changed this 2 to a 3, but we didn't over here, and again, and again. The high level takeaway I want you to have over here is yet again that having access to the indices in this list over here allows you to actually access what's in the list. It doesn't require you on the right to modify what's in the list in the first place. That's not possible because all you're doing is getting a copy of each of the elements in lm over here. Alrighty, so that's all we're going to talk about for memory today. Like I said, it's a lot, and I hope you have a better sense now of exactly how Python chooses to represent some of the information in your program. We're now going to go back mercifully to something a little lighter. I'm going to talk a little bit more about how exactly you can do some other things in lists. But before we do that, let's all take a break and join me on the other side.